Hello everyone, welcome to our experiment today, which is pipe friction experiment. Is one of the hydraulics experiments we have in campus in here, and as most of the other experiments we are using this general purpose hydraulic bench. This hydraulic bench consists of a water tank down there, which is feeding a pump, a water pump, centrifugal water pump, which then pump water to the attachment, whatever it is, and goes back to the tank and keeps circulating that way. The attachment today is a pipe friction experiment, in which we have a small test pipe. We got a test pipe, this metallic pipe, which has a 3 millimeter internal diameter, and we are taking pressure from 2 points at this pipe, starting point, end point. Now, getting the pressure difference between these 2 points will give us indication on the fluid speed inside, which will basically lead to a friction. We are getting the pressure value using these 2 mercury manometers here. Each one of them is connected from backside to one of these 2 points. So based on the mercury level, we are getting indication of pressure between these 2 points. This is the valve here, which is going to control the flow of water out of the pipe. We are going to change this in order to change the flow for taking different measurement sets. Okay? There is a setup need to be done into this experiment in order to perform laminar test or turbulent test. Okay, now if we look to the back side of this apparatus, we get some valve arrangement. This is the main pipe coming from the hydraulics bench, which come and feed through valve number 1. Now, based on the test we want to carry, we need to set these valves. We got 1, 2, and 3. We got 2 types of tests. Number 1, which is laminar flow, which is basically a low flow rate of water. In order to get that, we are going to open valve 1 and close valve 2. While doing that, we can see the water has no other way to go, only through this pipe. This pipe is going to feed water to the storage tank in here. This storage tank is going to store water up to a certain level. That level is decided by that overflow pipe. We are going to run the experiment in a while, and we are going to see how that is going to maintain a fixed height of water. That fixed height of water is going to supply water to the test pipe at a certain, because of gravity. Now water is going to leave the tank through this pipe here. So we need to make sure that valve number 3 is open. Now all these valves, how to know they are open or closed? Basically, if the handle is across to the pipe direction, means is closed. If it's inline like that, means it's open. So now we have valve 1 open, valve 2 closed, and valve 3 open. So water comes to the tank, up to the tank, then leave from the tank and goes through this pipe here to the test pipe in the front. Now if we follow this pipe carefully, we can see this pipe is supplying to the test pipe here. The test pipe then connects to the valve, which saw at the beginning here, which controls the flow outside of the valve. We get the flow out of the test pipe through this pipe, in which we are going to use some graded beakers to collect water in order to measure the volume. Okay, now I think we are ready to give it a start and see what happens when water all stops flowing. Okay, so we'll start the hydraulic bench from this switch, using this switch here. We always need to make sure this valve is fully closed before switching on. This to switch on. Now you can hear the pump starts running, but there is no water flowing because this valve is closed. We will start by opening this valve slowly, and we will notice water going up. Now you might wonder why there is this glass marbles in here. These are just to settle down the water flow as the water starts to go up. So now you can see water level start to rise up. Water will keep rising up till it reaches the overflow pipe up there, which is going to drain any extra water to maintain a fixed height of water. Now here there might be chances of water splash, so you should be careful, keep distance, and don't move the hydraulic bench or lean on it while doing the experiment. Now the water level is going almost there. We'll need to watch it, and we'll need to adjust the main valve of water to make sure only fixed level of water is there. Too much flow means the overflow pipe will not be having enough time to drain. Less water will mean water will keep fluctuating. Now we can see water is almost at the same level. If we turn this side here, we can see the overflow pipe is draining water and water is fixed at this level. Any additional water is coming from this pipe here down and goes through this pipe out here. This water doesn't relate to our experiment, and we don't care about the volume of this water. This water will get back drained to the tank and circulated again to the experiment. Now we have a water flowing and we have a fixed height of water. We can start doing the pipe friction experiment. Before taking readings, we need to make sure that these mercury manometers are 0, means they are both at the same level. Now we can see this one is reading about 21 and this is about 23. We need to get these leveled. So what we will need to do, we'll need to open this valve a little bit till we have some water flowing out there. You can see now water is coming out. We'll get this valve fully open at the beginning to make sure there is no air bubble trapped in there. We'll give it a few seconds for water to run out. Then we are going to fully close it again. So the reason for that opening was to get any air bubbles out of the system in here. Now after we close that, now the flow through the test pipe is 0 because the valve is closed and no water is flowing. Now at this point we can use these two valves. We'll both open them like that, and this is going to vent the mercury, both sides. We'll need to close them both together. These valves here up there, we'll need to close them both, and we should have about the same level of mercury. However, sometimes it gets really difficult to get these two levels at exactly the same point. So what we do, we note down their heights. This is, we are going to refer for it as H1 as per your experimental sheet, and this is H2. So the first set of reading we take it with 0 flow rate. We note down H1 and H2 to confirm our reference point. Now during this experiment, we are going to take only 4 readings during the lab, which is H1, H2, and the flow of water. The flow of water, we are going to calculate it using 2 measurements, which is basically the volume of water. We will collect a certain volume of water using a graded beaker, and we are going to time that using the stopwatch. So we'll have H1, H2, volume of water, and time. Then the rest of the table, we are going to do it while during the lab report. So all the calculated values, we can keep it later. We do only these 4 measurements during the lab. Then after the lab, you can have enough time to think about how to get the calculated value. We'll start now with a quick test on the laminar flow. This is again is a laminar flow because we are getting a small flow rate because of gravity from this storage tank. So how this all go? We'll start by opening this valve a little bit. Now this valve is sometimes we'll need more than one turn to change the flow. So we'll turn it out till we see a difference in here. Now as we opening the flow valve, we can see H1 and H2 are changing based on the flow rate. So let's set it at a certain level like that. Now we can see there is water flowing out in here. So if we consider this like a set of readings, so we can take H1, in this case it's about 20.5 centimeters, and H2 which is about 23.5. So H1, we can see the mercury level is about 20.5, H2 about 23.5. Now where is this 20 start from? What is it exactly? We don't really make any difference, because what we care about is the difference between these heights. So at the end, what we will do 23.5 minus 20.5, and this is the difference between these 2 points here. This is the pressure drop between these 2 points, which is important for us. So H1, H2. Now, if you look to the table you have at the end of your lab sheet, you should be able to know what I'm talking about. H1, H2, then we come to the volume of water. So before taking the volume of water, I'm going to reset this stopwatch, and at the same point, I'm starting to collect water. We'll need to make sure that the beaker is empty also. So at the same point we start collecting water, we are going to start with getting the time. Now we are going to collect water for a certain time. It doesn't really matter how much water or how much time we wait, because at the end we are going to divide these values to get the flow rate. But something important here to note it and remember it during your lab, this graded beaker here, well, it's going to fall, so let's stop now. So now we got certain volume of water. We can keep it here and talk about the point which I was just mentioning. We need to make sure a graded beaker should be always at lower level than this level here. So it should be always down. We cannot like get it the beaker here and we start collecting water. That is because this level here is going to be higher than the valve level, and that might change the flow rate. So always you need to keep this pipe here lower than the valve level. Then you collect water. So here we got a certain amount of water. So we will get the volume, we got the time, and this now we got a full set of readings, 4 measurements, H1, H2, volume and time. So for each type of test, which we have 2, laminar flow and turbulent flow, we are going to take multiple points, let's say 4 to 5 measurements, which should be enough to give you the details you are looking for. So now we covered laminar. Next we are going to go to turbulent flow. Okay, so now we are going to move to turbulent flow, but before we do that, I just want to show you something here. Now if we fully open this valve, we are going to get the maximum flow of water. The maximum flow of water should have the maximum difference in pressure in here. So this is fully open. We can see water is flowing from this pipe, and this is the maximum we get. 20, about 24. So we get about 4 centimeter maximum difference in laminar flow, or in the setup which we call it laminar flow, because in your report you are going to do the calculations and you should tell if it was a laminar flow or not. So keep this 4 centimeter in mind. We are going to change the setup now and see how turbulent flow will change. So before doing that, we'll close all the valves. So we will close this valve here. And we can see mercury levels get to about zero. I mean zero difference between them. Next, we are going to close this valve in here, the main valve, because we are going to do some adjustment in the valve behind the apparatus. So we should close this. So this is closed now. Now we will get back to our valves in here. Valve number 1, 2, and 3. In this setup, turbulent flow, we will need to have high flow rate going through the test pipe. So we are going to direct the water directly from the pump to the test pipe. So in order to do that, valve number 2 should be open, so water goes directly like that. But we still have the tank there. We need to isolate the tank, so both valve 1 and 3 going to be closed. So you can see now water comes from the pump, reach this point here. This is closed. It goes through valve number 2 straight. This is closed, then it keeps straight and come again to our test pipe here and directed out of the pipe. We can control it using that valve. So I'm going to open this valve just a little bit. We will not get water out because the main valve of the bench is closed. I'll just keep it open to see what I'm getting. Now, slowly and carefully, I'm going to open this valve, but looking into these mercury levels here. Now, you can see mercury is moving up and down, and with very high difference. Now before, if you remember, the 4 centimeters I mentioned, H1 was here and H2 was here. Now you can see as I increase the flow, mercury levels are increasing. I mean the difference between H1 and H2. So this sort of flow seems fine. Now we can go back to our control valve. We'll empty the beaker. We'll set the stopwatch to get ready for a next set of readings. Now for laminar flow, previously, I show you one example what we should take about 4 to 5 different readings. In here is the same case. So we are going to take 4 to 5 different readings. So we'll start with something a bit more than what we did previously. So I'm going to change this valve here to have a little bit more than 4 centimeter difference. Now if we see the difference here, we are having 19.25. So this is like, 6 centimeter difference compared to 4 in laminar. So we can consider this our first trial. So H1 is 19, H2 is about 25. We are going to start collecting water with time. We'll keep it for a while. Now in this turbulent flow, water flow is going to be faster, so it will require less time to fall. So now we are getting about half beaker finished. We'll get this out. Now always you will need to wait for this to settle a little bit and keep it horizontal and straight as much as possible. Now we can read a little bit below 200 milliliters. So this is going to be our volume and this is going to be our time, which is about 13 seconds. Now this could be trial 1. Trial 2 will be exactly repeating the same thing, but with more flow. How we know we have more flow? We should have more mercury difference in here. So if we come back and change this valve slowly, looking into these, now you can see they are changing, moving up. So this, for example, could be our second trial. Again, H1, H2, volume of water with time. So this is the second trial done, third, fourth, and fifth, and so on. So you can see now, if I get this valve open more, you can see the mercury levels are increasing. Now H2 normally at the up level is clean because always mercury is down. H2 is a bit dirty in here, but if you look closely you should be able to see the mercury level clearly. So now you can see H1 is 7 and H2 is 38. So we got about 31 centimeters difference compared to 4 centimeters. Now this is the end of the experiment. This is basically it. As I told you, 4 measurements only during the experiment and 2 setups for the valves to give us 2 types of flow. Now before we end this video, I would like to brief you about the safety aspects and risk involved with this experiment. Now I understand and I always say safety first, but I keep it last into the videos because I'm hoping that this will be the last thing you hear, so you will remember it. Now, as you know, if you are studying here, you know safety shoes are required in all our labs in the mechanical and automotive engineering, which is something general. You need to wear safety shoes before coming in here, regardless what you are doing. Now, specifically for this experiment, let me switch off the pump to make sure that you can hear me clearly. I will close this valve and I'm going to switch this from here. Now it's more quiet. So, safety related to this experiment. Before doing any experiment, you should make sure that you read the risk assessment form before coming to the lab. Read the lab sheet to make sure that if there is any safety instruction, you take care of it, or if there is any specific clothing, you wear it before you come to the lab. Now, as you see, this experiment deals with water and have electrical pump. Electricity and water are not good friends, and if there is any water leak or spillage on electrical connection is going to make problems. So always we need to make sure there is no water leaking, let's say from the valve in here, or from the bench itself on the pump, or into any of the wires. Now you can see the pipes are feeding to the pump from the tank, goes up there nearby the electrical control, the valve in here, and goes to the bench. So there is a possibility of leak from all these points. Now we do service this and we make sure there is no leaks before you come to the lab. However, sometimes it might happen. So if you notice any water leak on electrical supplies, switch off the bench immediately and inform a member of staff. This is number one. Number two, this attachment here is like fitted on the bench itself, but it is not physically fitted to there. You can see now I can move it around. Now there is a chance this might fall down, but of course not by itself. Only if somebody push it or somebody move the bench or lean on the bench. These all things you don't want to do it while the lab. Also that will affect the water level, which will give you wrong readings in there. So you should be careful while moving this apparatus. The other thing you need to keep in mind is the mercury. Mercury is dangerous chemical and we are using it in this experiment. If you are doing the experiment as the sheet said, and as I showed you before a while, you should have absolutely no problems. Just in case you have mercury coming out of the apparatus, you should not touch it or touch anything. Switch off the bench again and let us know. And last thing, water splash might come up from the tank is open, or from the pipes here if there is any leaks. So proper clothing is a good idea, and also again avoid movement to the equipment. Gloves, latex gloves or rubber gloves are available if you feel you are not comfortable dealing with water and get your hands wet. However, the water is not contaminated and being changed like in every while. So this is all. I hope you learned something from this video, and I hope you will learn more while you come to the lab. Thank you for watching, and sorry if it was long.